Okay, so I've now completed the wiring of the upper unit, which I did off screen due to the camera setup I have here. I couldn't really do that and show you while I was doing it without getting in the camera's way, getting in my own way, etc. But the layout of the unit is the motor driver here is considered the front of the top plate. And if I spin this plate around, you'll see that the bottom plate has a wide opening here, which goes towards the front of the B2. Okay, those are not aligned during normal sort of configuration, but they become aligned when you need to set the upper skin on or take it off. The way I've got this wired is I've got 4 of the slip ring wires, the grey and the black, I've got those paired as a ground, and then the red and the pink, I've got those paired as a power in from the underside. Over here, I've got a power supply connected. Those go underneath the Castle CC device, where I've got the 2 Wago connectors, one for positive, one for ground. So they're connected to there. The Castle CC is obviously connected to that as well to give it the power, and then wiring from the motor driver goes through this servo support across and in as well. So that's where it's drawing its power from. Output of the Castle CC device comes across. It's actually set to 5.1 volts, which they found was a good voltage setting for these servos. He found if it was at the standard 7.4 volts, he got a bit of jitter. Taking it down to 5.1 took that jitter away. So that comes around to a point over here, which I'll discuss in a second. The motor driver, power in from this side, and then the power out goes to the motor, kind of obviously. We have a 3-pin connection for the control of the motor driver, and what I have is that is taking the control line, a 6-volt out of the motor driver, which is there's an internal BEC here, so 6 volts out and a ground, and I'm taking those down through the slip ring, and then they are going to the RC receiver. So let's see here. So on this RC receiver, channel 4, I've got it set up. So this is the motor driver, and then the 6 volts and ground. Channels 1, 2, and 3, I have these wired, so they're coming up through the slip ring, and they're coming to a small board, which I've created up on the top here. This is another example of it. It's an array of header pins, and the way I have it soldered on the back is so that this row are all interconnected, and that is your ground. This row, all interconnected, and that is your power for your servos. And then each of these pairs is soldered together as well. So what I can do is I can take a servo, this is just a wire, but I'll show you. I can connect it to any of these, and then I can take the pin off and then off to a second point, in this case through the servo, through the slip ring down to the receiver. So that's the way I've got those wired. And I also have the outputs from the Castle CC device plugged into this board as well. So these servos are connected into a board like this, and the 5.1 volts from the Castle CC are connected here as well. I've done some initial testing. Power is correct, and the receiver I can actually move the servos. As you can see, we've got power on. We can move the servos all the way down so they are standing vertically, and then they move up to this point here. So the neutral point is actually there. I'll leave it roughly there at the moment. And then for head yaw, we've got these two front servos working against each other. And then head nod, the back obviously goes up while the front goes down, and you can have a bit of a yaw at the same time. And finally, the motor driver, we know that's working because I have that working. There we go. So those are all working. Okay, the next thing to do is to attach this top plate. Now I feel the easiest way to do this is to actually raise these arms to full height. Through each of these, there is a standoff, which is M4 by 0.7 threaded, 6mm outer diameter, 60mm length. So that is actually slid into each of these arms. Take 3 of these. And this one I'm needing to particularly bring in through this side because of the motor being in the way. That may impact me actually connecting the screws. Now, what will happen is these arms, obviously not in this orientation, will sit either side of these holes. And to stop excessive sliding or rattling in this position, we'll take some more of these 8mm by 1mm thick plastic spacers. So we need 2, 6. Actually, I think I may leave those off at the moment. They're just going to fall off otherwise. I'll put them on as I come to fitting it. Now, what we need to do is we will find the spring. Okay, there's actually a spring which will sit over this rod here through the center, and that creates an upward force at all times. I've got a quick video from Dave here which explains why he's particularly put that in, why he found it was useful. So I'll go over to that video very quickly.
In the video where I'm doing everything is very purposeful, like fast, you know? So this is what I call 50% of the character. So you have the high functioning, high emotional happiness. But when you want to be sad and small and subtle, that's where I think a lot of it comes in. So if you notice, if I go very slow, there's a lot of jitter. And this is inherent of these Reef servos. They love to move really fast and be really strong. So what does that mean? It means this head, these servos want to see way more weight than what this has on top of it. And that's something we don't want to do. We want to make it light. So we get the performance level here, you know, but we don't get the subtle, even when it's low, we don't get that subtle emotion. And how I can show an example of this is if I were to change the head height from 3 position to proportional. Okay, I did that there. So if I just run this up and down an analog stick, look at that. So going up is no problem. There's weight there. Going down, there's no resistance. So, and I think it'd be neat to, like, you know, do those type of movements where he's looking up and then you're just kind of hiding, you know. So I know you're looking at B the whole time, but trust me when I say he wants to be better. Put some springs pushing tension on that platform going up. So it's pushing up, so when it's pulling down, it has resistance. And the results are interesting. They smooth it out much better. So I can go smooth. I'm actually pretty happy with that, to be honest with you. So I think there's something that simple. I did notice in the original mech video, when I had this inspiration, they had a spring there, but I was wondering if it was more for something else. But now I'm like, wait a minute. I think this may have done it.
Okay, so putting the spring on the center spar, and then just slide it through the bearings in the center and try and roughly align these yokes with the servos. And just prop this up in the hope that you can see a little bit better. So I'm going to try and slide out immediately. Get the screws. For attaching these, we're going to use M4x16 button head screws. Button head because they're nice and small. They're not going to really catch on any of the componentry down here when the arms are at full sort of retract. Okay, so plastic on one side, plastic on the other. And I apologize if this isn't giving you a particularly good view. For one of these, I'll try and turn it totally on its side and I hope that you can see a bit better. Other side, I'm just going to have to put it in finger tight at the moment and try and get my elbow out of your way. Okay, let's see if I can put this on its side now for you to see the last one. I should have mentioned as well that this hole at the front here for a magnetic connector should be to the front of the droid, so facing the motor driver. I have that just about balanced. Hopefully it'll stay up for me. So taking these two 1mm spacers, one on each side, just for aesthetics to make it the same as all of the other ones. Spin that around. We just slide over. Remembering the spring's actually starting to act now. Okay, I'm going to struggle to get this one in as well. And actually move it by hand a bit higher. And in action, the servos will never be this high. The servo arms, I should say. That may be way too close to the camera for you to actually see now. There we go, those were fitted. Okay, so we actually have power now. The receiver is connected. Okay, that clicking that you can hear is just where the spring is just catching on itself slightly. So nothing really to be concerned about there. Okay, let's bring it halfway up. There we go, we can get some nice movement there. Okay, that's the head fully down. So that effectively completes the build of the head mechanism. Obviously it needs to go into the droid now. So I will be looking at the skins and how to mount it quite soon. Okay, I just want to quickly talk about the skins for this modification. From this skin upwards, pretty much everything is changing. Everything down from this is just the standard Mr. Baddeley B2-EMO model. Construction of this is pretty similar to the original model in that we've got the four corners print separately and then the four sides print separately. We also have the little electronic detail board, which is magnetized in. It's using similar screw-in magnets to everything else on this. Is quite a nice thing, so you never have to worry about getting the polarity of the magnets the wrong way around. Similar to Michael Baddeley's, there are six L-shaped brackets that go in here, 5 narrow ones, and then at the front there's a wider one. The one at the front is wider because on the bottom side it will have 2 pogo pin connectors mounted, and those will come down onto the top plate, which is the end of here. The top plate of the lift mechanism, which will have mating connectors here, and it will connect. This will give you connections for LEDs, for instance, on your risers, and for your sound. For the LED lights in the risers, Trevor has designed some PCBs which will screw into here. They've got the RGB addressable LEDs, so we'll be able to change colors, play a rainbow, whatever you want to do with them. With those RGBs, what we've got is we've got one wire coming in from the connectors through to point 1, and then from here it will go around, and we just really daisy chain them together. There are no lights on the rear right riser. For sound, we're using Dayton Audio EX32Q2-4s. These use a VHB tape, and we'll have one of these in each corner of the body. Nice thing about these is I believe you can unscrew the back here. I can't get it at the moment, but the mount actually unscrews and screws in. I managed to get it. So the mount will actually double-side tape in here, and there is a little shelf which will give you an indication of where to stick it, and then it just screws on the back. It does mean that if you ever decide to change them, you can, whereas previously if you just VHB taped them in there, that was them, they were in there permanently. On the bottom side of these L brackets, you'll see there's 4 M3 heat sets. One at the end is for a magnet, which will match the magnets on this plate and hold the body together. And then the other ones will be going through the body. There's also 2 heat sets in the body itself, which screws will be used to hold it in place. So it's M3 by 12, which will hold these L brackets into the body. So, and then from the bottom side, it will be M3 by 6s in these first 2 positions. And then there's actually an M3 by 20, which will come through the bearing on the bottom side. On the bottom side, the bearing has a clearance hole drilled. It will come through and it will mount into there. Okay. That's pretty much it. As a description of this part of the build. So I've now completed the assembly and fitting of the head mechanism into my droid. Just to show you some basic movements, we can roll the head, we can spin it using the polar loop motor, bringing it back to the front. And you can tell the front by the pogo connector on the top here, and then we have the raise and lower. As you can see, we have pogo connections here, which will take the sound signals and the light control signals and power signals to the risers, so we can light up the risers. Through the slip ring in the center, we've got 24 volts coming up to below the Castle CC back, where there's a distribution Wago connectors. So 24 volts to the back, 24 volts also to the motor controller. The back has given us 5.4 volts, which is coming around here to a small distribution board that I made for myself, which allows me to distribute power to the servos and all the control signals coming up through the slip ring as well. So that is the final installation of the head mechanism. And I'll show you some video with the body fully built as well. Okay, so here is a general look at the movement of B2-EMO on the completed droid with the new head mechanism. So it's the standard lift mechanism for the body, and we can lean him around various places. You can see the LED light sets of the risers and the eye. These are Trevor's PCBs from Greenwave, his website. I'll put a link in the description. Lifting the head mechanism, we can then tilt it in all directions, and then obviously spin. And one last light charging light sequence that's seen in one of the episodes. I can't actually remember which one, but again, that's within Trevor's PCB set. And that is the general movement. So now the build's complete, and I hope this helps some of you with the building of your own head mechanism, whether it's David's or just inspired by this design. Just ending this video now, I'd like to thank Michael Baddeley, David Ferreria, Michael McMaster and Trevor Sarachuk for their help on this build. And finally, I'd like to encourage you to look into supporting a STEAM organisation such as the Grant Imhara Foundation, the Teresa Sondra Jacobs Foundation, or some other body local to yourself. Good luck with your builds, and may the force be with you.